Uniform distribution. Uniform distribution is a probability distribution that has equal probabilities for all possible outcomes of the random variable. It is also called the rectangular distribution. This is the probability density function for uniform distribution. So this shows that for random variable x ranging from a to b, the probability density function is a fixed value. It's 1 divided by b minus a. Here, a and b are two important values or parameters of uniform distribution. We show uniform distribution by these two values. For example, we say if x follows a uniform distribution with parameters a and b. F of x is the value of density function and x values. A is the minimum value that x can take. B is the maximum value that x can take. So this means that for value less than a, the probability density function of x is just 0. Also, this is true for the values greater than b. So the probability density function of x is 0 if x is greater than b. So less than a or greater than b, the probability density function value is equal to 0. Between an a and b, the probability density function is equal to 1 over b minus a. Properties of uniform distribution. The mean of a uniform distribution is a plus b divided by 2. And the standard deviation is a square root of b minus a squared divided by 12. Let's see an example for uniform distribution. Suppose x is a random variable that follows a uniform distribution over the range of between 2 and 6. Characterize the probability distribution and also find the mean and standard deviation of x. So here we have the values of a and b. A is 2 and b is 6. Based on this, we can find the probability density function, which is 1 over 6 minus 2. Also, we can plot the distribution for, as we see here, this is the probability density function, 1 over 6 minus 2, which is 1 over 4. So these values, this probability density function is true for values of x between 2 and 6. So that's 1 over 4, which is equal to 0.25. And that is where we have here the height of this rectangle is 25%, which is the probability density function values. And x is going to be between any range between 2 and 6. We can also calculate the average and standard deviation of this uniform distribution. The average is a plus b divided by 2, which is 2 plus 6 divided by 2, which is 4. So the average is 4, and the standard deviation is 1.1547. A follow-up question. In the previous question, what is the probability that x takes a value between 3 and 5? So we know that x is uniformly distributed with a equal to 2 and b equal to 6. To find the probability that x takes values between 3 and 5, if you want to do it mathematically, we have to solve this problem of integral. The integral of f of x, d of x. So we know that f of x is the probability density function is 1 over b minus a, which is 1 over 6 minus 2, which is 1 over 4. So the probability density function is 1 over 4. So this would be f of x d of x, which means it's 1 over 4 d of x from 3 to 5. 3 to 5. If you solve this integral, that's going to give you the probability, which is equal to x over 4 for values of 5 and 3, which is equal to 5 minus 3 divided by 4, which is 2 divided by 4, which is 0.5. So the probability is 0.5. But there is an easier way actually to do this, not using the mathematics. And that's by using the plot of the distribution. So we know that for continuous distribution, the probability of a value the random value between two values here, which we have 3 and 5, is actually the area, the shaded area between 3 and 5 of the probability density function. So if we plot the distribution here, which is going to be something like this. If this is 2 and this is 6, then this comes here and I have to get rid of this part, make it like this. So the probability of x between 3 and 5 would be 3 is here and 5 is here. So the probability of x between 3 and 5 would be this shaded area, the area of this square here. It's not a square actually, it's a rectangle. And so the area is height multiplied by the base. So the base here is 3 to 5, that's 2. The base is 2, 5 minus 3. So the base of this shaded area is 2. The height is equal to actually the probability density function value, which is 1 over 4. So that's 1 over 4. So the area here is base multiplied by the height, which is 1 over 4, the height multiplied by the base, 2. 2 is 5 minus 3, and that's 0.5. All right, this is 0.5 is the area of this yellow square here. The base here is this, which is 5 minus 3, which is 2. So the base is 2 multiplied by height. Height is 25%, which is 1 over 4. That's the 1 minus b minus a, which is 1 over 6 minus 2, which is 1 over 4 or 25%. So the probability is 50% or 0.5.